Hello students, myself XI-Sci Gorane, Rayat Shikshan Sanstha's RBNB College Srirampur. I am junior college teacher in physics. Now in last 3-4 lectures, you have studied about optics from 11th science, different concepts related with optics. You know optics is a science of light, and you studied the reflection, refraction, then total internal reflection, and the application of that total internal reflection, that is optical fiber. Now today we study the phenomenon related with light, that is the dispersion of light. Before dispersion of light, we firstly try to understand what is meant by monochromatic light. Monochromatic light. The light having the single wavelength or only one wavelength is monochromatic light. Single wavelength or only one wavelength is a monochromatic light. For example, sodium vapor lamp emits a monochromatic light which consists of a single wavelength. Then we study polychromatic, try to understand what is polychromatic light. Poly means many. The light which consists of different wavelengths or number of wavelengths. Number of wavelengths are there in a light. Single wavelength, monochromatic, sodium lamp. Polychromatic light which consists of number of wavelengths or different wavelengths is a polychromatic light. For example, sunlight or white light, we say white light. It consists of different wavelengths, that is the different colors ranging from violet to red. 7 colors are there. Extreme colors are violet and red. In between violet and red, there are 5 different colors. You know the sequence VIBGYOR. Violet, indigo, blue, green, yellow, orange and red. So white light consists of these 7 colors, hence 7 different wavelengths. It is a polychromatic light. Now we study one important phenomenon related with light, that is the dispersion of light. Very interesting phenomenon, dispersion of light. You know polychromatic light. White light is a polychromatic light. It consists of 7 different colors. If such light is passed through a transparent material, it gets split up into 7 colors or its constituent colors. And this separation of light into its constituent colors is called as dispersion of light. Very simple definition. Separation of light into its constituent colors is the dispersion of light. There are 2 types of dispersion. First is angular dispersion. Angular dispersion, and second is lateral dispersion. Lateral dispersion. Firstly we see what is the angular dispersion, and then we see the lateral dispersion. angular dispersion. These concepts are very simple. Now, color of the light depends on the frequency of ray or frequency of wave. For different colors, frequencies are different. Color depends on the frequency. Refractive index of material, that may be glass, water, it also depends on frequency of light. For different colors, hence refractive index is also different, because a refractive index depends on the frequency. Color of light also depends on the frequency. Hence, for the different colors, refractive index of material is also different, and the refractive index increases with increase in frequency. If frequency is increased, a refractive index also increases. Suppose this medium is vacuum or air, and this medium is a transparent denser medium. This part is a denser medium, and this is a vacuum. Suppose this is a normal. We see the angular dispersion here. If white light, that is the polychromatic light, is incident obliquely here, this is the white light. If this denser medium or this transparent material will not be there, this light will travel along this straight line. So this is the direction of incident light. But as this transparent material is there, so at this point the ray is refracted into 7 colors. It is refracted. For the convenience, we show only extreme colors. Suppose this is violet color and this is red. In between violet and red, we know there are 5 colors, because white light is made up of the 7 colors. This is the direction of incident light. So this red color is deviated by this much angle. This is the angle of deviation for the red color, delta R. Angle of deviation for the red color. Deviation of violet color is maximum, so this is angle of deviation for the violet color, this much angle, delta V. This is the angle of deviation for the red color, and the difference between these two angles is this much, that is delta VR. Delta VR, and this delta VR is nothing but the angular dispersion, and it is delta V minus delta R, and it is called as angular dispersion. Angular dispersion for the extreme colors. That is the angle of deviation for violet color, it is maximum, minus angle of deviation for the red color. So this is the angular dispersion. For this obliquely incident ray, the angle of refraction are different. Angle of refraction are different for the different colors, and they are separated, or they disperse and travel along the different directions, causing the dispersion of light. This is the angle of deviation for red color, angle of deviation for violet color, and angle of refraction is different for these colors. These are the angle of refraction, and due to this different angle of refraction, they separate or they disperse and travel along the different directions, and we call it as a dispersion of light, and as it is measured in terms of angles of the deviation, hence it is called as angular dispersion. And that angular dispersion from the figure, it is delta Vr and it is delta V minus delta R. So this is the angular dispersion. Now we see the second important part, that is lateral dispersion. Lateral dispersion. We know dispersion. Two types of the dispersion, angular dispersion and lateral dispersion. Now for lateral dispersion, we consider a parallel glass slab. This is the glass slab having parallel surfaces. This is the transparent material. We call it as a denser medium. Again, suppose this is the normal, that is the perpendicular to the surface, and if white light is incident here, obliquely incident, this is the polychromatic light, or it is a white light, and then it is dispersed. And if this transparent material is not there, this light travels like this along the straight line. It goes without any deviation. At this point, the ray is again refracted. This is violet. This is red, but these refracted rays moves parallel to this incident light after the refraction. It moves parallel to incident light. That is the direction of incident light. Like this. This is the incident light, or this is the white light, polychromatic light, white light. Angle of incidence, this is angle of refraction for the violet, we call it as RV. This is the angle of refraction for the red, we call it as RR, angle of refraction for the red. Then automatically this is I minus RV, this much angle is I minus RV, and this much angle is I minus RR, I minus RR. This is the ELR, this perpendicular distance is LR, LR, then this distance is LV, and here lateral dispersion is LVR. This much is the lateral dispersion, that is LVR, and this lateral dispersion is lateral dispersion LVR is equal to LV minus LR. This lateral dispersion is LV minus LR. This is LR. Laterally displaced red rays. Violet ray laterally displaced, LV minus LR that is LVR is LV minus LR, and this is the lateral dispersion. It means the rays are laterally dispersed. Here polychromatic light, that is the rays of different colors, a bundle of different colors, that is the white light, is incident here on the parallel transparent slab, and emergent light consists of all colors. For the sake of convenience, only extreme colors, that is violet and red, are shown. In between violet and red, there are 5 colors we know. Emergent light consists of the all colors separated out, and they move parallel to this direction of the incident light. They are laterally displaced. The colors are parallel to each other, and they are also parallel to the direction of incident light. These are the parallel to each other. Also parallel to the direction of the incident light, and this is nothing but the lateral dispersion. It is measured as a perpendicular distance between direction of incident ray and respective directions of dispersed emergent ray. Perpendicular distance. Angular dispersion is in terms of the angles. This lateral dispersion is in terms of the distance. For easily detectable lateral dispersion, the parallel surfaces of the slab must be separated over a large distance. Otherwise, it is not easily detectable. This distance between the slabs must be large. Hence, it is not useful. Hence, a prism is used. Prism is used. Now, what is the prism? See, prism is a transparent material. Suppose this is a prism. This is a prism made up of glass. Glass is a transparent material. There are 3 rectangular faces. This one, and this one, and 2 triangular faces. 3 rectangular planes, 1, 2, 3, and 2 triangular planes, this one and this one. This one is triangular plane, this one is also triangular, 2 triangular planes and 3 rectangular planes made up of the transparent material like glass. These 2 are the refracting faces of the prism. These 2 rectangular faces are the refracting faces. The line joining the refracting faces, or the line along which 2 refracting faces meet, is the refracting edge of the prism. Is the refracting edge. The angle between these 2 plane surfaces or refracting surfaces is the refracting angle. And the section of prism perpendicular to its refracting edge is the principal section of the prism. Section of the prism perpendicular to its refracting edge is principal section of prism, and this principal section is a triangular in shape. Principal section. The face of the prism opposite to this refracting edge, means this face, it is the base of the prism. Section of the prism perpendicular to refracting edge is principal section of the prism. The principal section is a triangular, and the face of the prism opposite to refracting edge is base of the prism. So this is about the prism. This prism is a transparent material bounded by the 2 plane surfaces inclined to each other. These are the refracting surfaces. There are 3 rectangular planes and 2 triangular planes. So this is the prism, and we study the dispersion of light through the prism. Now for the prism, as we know, prism, its refracting angle, base of the prism, principal section of the prism. Now we see the refraction through the prism. Firstly, for the monochromatic light, and then for the polychromatic light. How the light is refracted, monochromatic light and polychromatic light. So our next article is refraction through prism for monochromatic light. Refraction through prism. And you know monochromatic light, light having the single color or single wavelength, like sodium vapor lamp. Monochromatic light, single wavelength light. Suppose this ABC is a principal section of the prism. We know the principal section of the prism is triangular in shape. This is a refracting angle of prism, we know. If monochromatic light is incident obliquely at one face of the prism, if prism is not there, this light will travel along the straight line path shown by this dotted line. This is the direction of incident light, and this light is monochromatic light having the single wavelength. At this point the ray is refracted, that is, it changes its path. This is the incident ray. This ray is the refracted ray. And again on the other face it changes its path, that is, it is refracted again. This is the refracted ray. If this refracted ray is produced backward, this is the direction of the incident light. If prism is not there, the light travels along this straight line. And if this refracted ray is produced, it means this ray is deviated through this much angle. The incident ray is deviated through this angle, and this angle is denoted by delta. This is refracted ray, and one main thing is this is emergent ray. Emergent ray. This emergent ray or this incident ray is deviated through the angle delta, and this delta is called as angle of deviation. Angle of deviation, that is, the incident ray is deviated through this angle. Here ABC is the principal section of the prism, BC is base of the prism, A is refracting angle of the prism. The ray is refracted at 2 points, and the incident ray is deviated through the angle delta, and delta is called as angle of deviation. So this is the refraction through the prism for the monochromatic light. Now if white light is incident on the prism instead of monochromatic light, if we consider the refraction of polychromatic light, that is the light of different wavelengths, polychromatic light. For polychromatic light, we know it is made up of different wavelengths, hence different colors. Polychromatic light is made up of the different wavelengths, that is the different colors. This ABC is a prism. This light is a white light, or we call it as a polychromatic light. If prism is not there, this light will travel along this direction. This is the direction of the incident light. At this point, the ray is refracted, and angle of refraction is different for the different colors. It is dispersed into 7 colors. Here, for our convenience, we show only extreme colors. Suppose violet and red are the extreme colors. And again, this is the refraction here. Deviation for the violet color is maximum. Deviation for the red color is minimum. We produce these rays again backward like this, and suppose here this is refraction for the red. And if we produced here, we get the angle of deviations. See here, this is violet, this is red, violet. In between violet and red, there are 5 colors: violet, indigo, blue, green, yellow, orange, red. Angle of deviation is maximum for the violet and it is minimum for the red. This is delta R, angle of deviation for the red color. This is delta V, that is the angle of deviation for violet color. Violet and red are the extreme colors. In between these two, there are 5 colors, and here the refraction of this polychromatic light through the prism we see here, it is dispersed. The separation of light into its constituent colors, we know the dispersion, and after emerging from the prism again we get the 7 colors. Violet and red are the extreme colors. Deviation of violet color is maximum, that is delta V, angle of deviation for the violet, and deviation of red color is minimum, that is delta R, angle of deviation for the red color, delta R, and this delta V is greater than delta R. Angle of deviation of intermediate colors are in between delta V and delta R, and here this angular dispersion is delta VR, and this angular dispersion for the extreme colors, that is delta VR, and that is equal to delta V minus delta R. So this is about the refraction through the prism for the polychromatic light. Okay. Today we stop here. Thank you.